Now, if you look at some quantities, you'll notice that some quantities change with respect to other quantities. For example, or some variables change with respect to some other variables. If you look at health, for example, if you feed well, you grow well. If you feed poorly, you probably lose your health or something else, or you fall sick. All right. So that's one quantity, food, with respect to the quality of health a person gets. So there's, you can relate so many quantities. For example, speed and time. All right, speed and distance, and there are so many quantities like that that you can relate with. So in this video, I'll be explaining direct and inverse variations, how you can relate quantities using the direct and inverse variations. If you look at the quality of food you eat, let's say the quality of food you eat is Q, and the health of a person is H. So if you feed well, you know that you grow well. So let's say we measure the quality of food the person eats. So say we have 5, 10, 15, 20, like this. All right. So we say the quality of food that a person eats is proportional to the type of health he gets, either good or poor health. So either good or poor health. So if quality of food he eats is 5, he probably will get poor health. But if the quality of food he eats is 20, let me write this like this. Let's put this as poor and good. If the quality of food he eats is, let's say, 15 on the scale, you'll get to good health. So you see, as the quality of food increases, his health also increases in the same manner. You notice that we're relating one quantity with the other quantity, and this will lead us to direct variation. Here we say that the quality of food he eats is proportional to the kind of health he gets. So this is a type of variation called direct variation. In this type of variation, the quality of food the person takes is directly proportional to the type of health he gets. If he eats very well, he gets good health. If he eats poorly, then he falls sick. Okay, so this type of variation is called a direct variation. So we could just say the quality of food the person takes is directly proportional to his health. Now this symbol here represents direct variation. All right, now to remove the symbol so that we can change this to an equation, we'll just remove the symbol, put the equal sign, and immediately remove the symbol to introduce the equal sign. Then the constant of proportionality will be introduced, and this will be K times the H we have here. All right, this K is called the constant of proportionality. It's called the constant of proportionality. So this type of variation is called direct variation. When once the quantity is increasing, the other quantity is increasing, or as the quantity is decreasing, the other quantity is decreasing. Let's try an example here. This says if y varies directly as x and y equals to 12, x equals to negative 13, find y when x equals to 16. This says if y varies directly as x. Notice this statement, varies directly. Okay, that means direct variation. After you've represented y and x like this and added your symbol for proportionality here, you can now change this to an equation. This becomes y is equal to, immediately remove this sign of proportionality, then a constant is introduced. I'll use k to represent the constant, then this will be x. This is our relationship here. This now says, and y equal to 12, x is equal to negative 3. You will use these first values of x and y to get the value for the constant of proportionality, which is k. We need that constant of proportionality before we find y. We'll substitute y to be y for 12 and substitute x for negative 3. Alright, negative 3. Now we need to get k. To get k, I'll just cancel negative 3 from the right hand side. Whatever I do to one side, do to the other side of the equation. So this cancels this, and 3 goes here 1, 3 goes here to give us 4. you see we have -4 on the left hand side equal to k. That means constant proportionality equal to -4. I can just go here and just say y is equal to k is -4. Just replace -4 times x. Now this is our relationship, our new relationship. This now says find y when x is equal to 16. So I'll just substitute 16 here. I'll have y is equal to -4 times 16. Y is equal to 16 times 4 here will give us 64. This will be -64, and this is the value of y. That's all. This is how you work with direct variation. Now the next type of variation I'd like to talk about here is the inverse variation. You know, sometimes for direct variation, I said for direct variation, one quantity is increasing as the other quantity is increasing. But for inverse variation, the case is a bit different. For inverse variation, as one quantity is increasing, the other quantity is decreasing. A very good example is speed and time. Now, so let's say I'm going to my house. If I'm driving at, let's say, 20 kilometers per hour, and I just decided to change from 20 kilometers per hour to 50 kilometers per hour, the time it will take me to get to my house driving 50 kilometers per hour will be less compared to the time it will take me to travel with a speed of 20 kilometers per hour. So let's say with 20 kilometers per hour, I get to my house in let's say 5 minutes. But with 50 kilometers per hour, I'll get to my house in 2 minutes. Now you notice that as the speed increases, the time decreases. So this is another type of variation, and this type of variation is called inverse variation. As one quantity increases, the other quantity decreases, or as one quantity decreases, the other quantity increases. So here we're talking about distance and time. Here we'll just say the distance is inversely proportional to time. Because it's inverse, this will be 1 all over t. Alright, it's inversely. For directly proportional, we just say d directly proportional to t. But because this is inversely, you would say 1 all over the second quantity. Now to remove the inverse variation, I will introduce the constant of proportionality times 1 all over t. Let's go to this example here. It says if r varies inversely as t and r equals to 18 when t equals to -13, find r when t equals to -11. I'll just say r varies inversely, that's 1 all over t, varies inversely as t. Alright, so that's r varies inversely as t, 1 all over t. This becomes r is equal to k. I've removed the variation symbol, so I introduce the constant of proportionality times 1 all over t. This becomes r equal to k times 1 gives us k all over t. Now this is r equal to 18 and t equals to -3. We can use this to find the constant of proportionality. R equal to 18, t equals to -3. We can easily find k. I'll cross multiply to be 18 times -3 equal to k times 1. 18 times 3 here will give us 54. Because of the negative sign, we have -54 equal to k. So since k equal to -54, I could replace here. I'll have the relationship to be r equal to -54 all over k all over t. And this is our relationship. Now we are asked to find r when t equals to -11. We'll have r is equal to -54, t is -11. Now we are dividing two directed numbers, that's minus cancel minus, we have plus. 11 goes in 54 4 times. Alright, remember what, 4 times 11 is 44. Subtract 44 from 54, you'll be left with 10. So remember 10. I just changed this improper fraction to mixed fraction. Alright, so r equal to 4 number 10 all over 11. This is how you solve problems on direct and inverse variations. I advise you to go to the exercises and solve some of those problems.